How's it going, guys? My name is JP, and welcome back to JP Math. In this video, we're going to be going over quadratic equations, just the introduction to quadratic equations, going over some of the basics. And this is going to be a continuation of the last video of Algebra Review, which just went over linear equations. So quadratic equations I'm going to get to in a second, but they're in a different form than you normally expect as opposed to linear equations, and they're also extremely important in all aspects of graphing and mathematics. So let's get right into it. So again, what are quadratic equations? That is the question. Well, they come in this form right here. Now they can be rearranged into different forms, but this is essentially the baseline form where it is very easy to solve for. So in most cases, in order to solve for x, you'd actually just make this into a 0. So in most questions, this is just going to be all this is going to be equal to 0, and you can essentially just solve for x. Now, in the other form for linear equations, you'd have ax plus b equals 0, and you could very easily solve for x. It was very simple. But now we have to take into account we have a x squared in this equation here, which is why it's a quadratic. That's what that means. So what are we going to be covering with these quadratic equations? Like what kind of things are we going to go into? Well, the first thing that this video is going to cover is quadratics with a leading coefficient of 1. So basically, it's this form here, except the a is just equal to 1. So a equals 1 in that case. So that's what we're going to be covering in this video. In the next couple of videos, I'm going to go over leading coefficients other than 1. So a, when I mean coefficient, by the way, I mean like a, b, or c. Those are, not c, but the ones in front of the variable x. So leading coefficient of other than 1. So a could be 2, 3, 4, any of those. So that'll be a video separate as well, because there's a different technique. And then we have the quadratic formula and complex roots. It's weird because you can actually get imaginary numbers for quadratics. We'll get into those details in a future video. And then the last thing is completing the square, which is actually something I've gone over relatively recently in my engineering field. So that's an important concept to know as well. So let's get right into it a little bit. Let's go over the basics of factoring. Okay, why do we want to factor? Well, essentially we factor to simplify the equation and make it easier to solve for the roots of the function. So what do I mean by that? Well, here we have an example. We have a leading coefficient of 1. We'll get into the more details in a second, but x squared minus 6x minus 16 equals 0. Again, this would be y normally, but we're making y equal to 0. So when you factor it, these are the same equations, but this one's just simplified. If you wanted to solve for the roots of this function, all you would do is you set both of these parentheses separately equal to 0. So let me show you really quick. So x minus 8 equals 0, and x plus 2 equals 0. Okay. Now, here you have two linear equations. You can just solve for x. So x equals 8 and x equals negative 2. Now, these two would be the roots of this function. And now, what do I mean by roots? Because that's a term that I'm going to be throwing around. But let me clarify that really quick. So, when we take a look at this is our function right here. It's graphed right here. This line is our y-axis, and this line is our x-axis. As you can see here, when we put y down to a value of 0, you see we have a couple different values that cross over the x-axis, and those values are the roots of our function. So as you can see, here you have x equals negative 2, and then x equals 8. So when you're finding the roots of the function, you're just basically finding where the graph crosses over the x-axis. So let's get into our first example question. I'm going to give 3 example questions for each of these topics, just to go a little bit more in depth on it in regards to the problem solving process. There we go. All right, so here we go. Leading coefficient of 1. You can write the 1 there if you want to. Sometimes we'll just leave it as x squared. To solve these kind of problems, you're going to want to make a t-chart. So just bake a t like this. And you're going to put a number in this spot first and a number in this spot. Now, the number in this spot is essentially going to be whatever number is here, which is 1, and you multiply it by the number all the way on the end without a variable. So 1 times 6. Now that variable is going to go right there. The next one, this spot right here, you're just going to plug in whatever number is in front of this x right here. So that'll be negative 5. Okay? Very simple. Now, the purpose of this t-chart is we're going to find 2 different numbers that will multiply up to this number, And those two numbers also have to add up to this number, but they have to be the same numbers. That's the trick. So let's take a little look here. Ready? We got 2 times 3. What does that equal? 2 times 3 equals 6, right? All right, so that meets that condition. What about 2 plus 3? Well, that equals positive 5, which does not equal negative 5. So that condition is not satisfied. So this is not valid. Let's try another one. What if we did negative 2 times 3? Well, that equals negative 6. That's not going to work. What if we did negative 2 plus 3? Well, negative 2 plus 3, that's just going to be positive 1. That won't work. So obviously, if one of these isn't correct, then they both won't work. So now let's try negative 2 times negative 3. Right, negative 2 times negative 3. Let me actually rewrite that just to make it a little bit cleaner. That's bothering me. Just because I need to make it a little bit nicer. So negative 2 times negative 3. Well, that equals 6. What about negative 2 plus 3? That equals negative 5, right? So both of those conditions are met. So you found your golden numbers that we're going to use to factor this equation. So now you have these numbers. Now what's the next step? Well, you want to put it in this form right here. So you have an x minus your first number in parentheses, and then multiplied by x, or this should be plus actually, x plus another number that you found in parentheses. And all that equals 0. Okay, so let's plug our negative 2 into here and our negative 3 into this spot. So you just have x minus 2 times x minus 3 equals 0. So when you solve both of these individually, so x minus 2 equals 0, and then x minus 3 equals 0, you'll find that x equals 2 and x equals 3, just like that. So if we were to look at this on a graph really quick, just to give you an example, this is a very poorly drawn graph, but this is our x-axis, this is our y-axis. Just give like a rough sketch here. This is a very like thin parabola basically, but basically x equals 2 right here and x equals 3 at these locations. So typically for quadratics, you're always going to have two solutions no matter what. They could be the same sometimes, but you're going to have two solutions no matter what. That's just an important fact that I forgot to mention earlier. So let's get into the second example. So you'll notice that this is not in the standard form. Remember, our standard form is ax squared plus bx plus c equals 0. As you can see, this is not the right form. So first, we're going to rearrange this to the proper form. So we're going to move all these variables, or all these things, over to the other side. I love how I just call these things. This is a whole number and this is a variable. Please don't get that confused. So let's move those over. Plus x minus 12 equals 0. Okay, so now remember we have a leading coefficient of 1. So we're going to make our t-chart. So let's go over here, make our t-chart. Remember, this number and this number are our key starting points. So remember, 1 times the far number, that's negative 12. And then whatever number is right here, if there's not a number here, you can just assume that's 1. So that's just positive 1. So we just put a 1 right there. So same technique as before. What times what equals negative 12? Well, let's try negative 6 times 2. That equals negative 12. What about negative 6 plus 2? We're going to put a little check mark there. That does not equal 1. So these conditions don't work. Let's try negative 4. Oops, negative 4. It's being annoying right there. Negative 4 times 3. Well, that equals negative 12. What about negative 4 plus 3? Negative 4 plus 3 is negative 1. That does not work. So that is a no-no. What about the opposite? Let's do negative 3 times 4. That works. Negative 3 plus 4 is 1. So that works. So you now have your two numbers that you can work with. So let's put it back in our form. So this will just be x minus 3, because that 3 goes right here, and then times x plus 4. And that 4 goes right into that slot. And that equals 0. So again, you can just solve for, set both of these terms individually equal to 0, and you get x equals 3 and x equals negative 4. So let's just plot that out really quick. Obviously, these full parabolas aren't going to look exactly correct, but I'm just showing you where the roots would lie. So you have -4, which is about right here, and 3 is about here. So you'd have a parabola maybe looking like that, approximately, right? So -4 is there, and you have +3 right there. So that is the roots for this equation. And here we have our last one. So if you want, you can pause the video now and try to do this by yourself. But I'm going to go ahead and go through this a little bit quicker now. So we have leading coefficient 1. We have our t-chart right here. So this spot would be just 15. And this spot would just be -8. So you know 3 times, see, this is where you can kind of start doing it like a little bit ahead of time. So in your head, 3 times 15, that equals 15. But 3 plus 5, or no, 3 times 5 is 15, but 3 plus 5 does not equal -8. But what if you did -3 times -5? That equals 15, and then -3 plus -5, that equals -8. So it's good to start doing this process in your head a little bit. If you need to write it down, that's good, but it's always good to start getting a little bit faster with this method, I guess. Just, when you start doing tests and stuff, it's helpful. So let's plug this in down here. You just have x minus 3 times x minus 5 equals 0, and you'll find that x equals 3 and x equals 5. Quick little graph just to demonstrate right here. Again, you have x equals 3, x equals 5, and something like that. Now, sometimes you'll have a parabola open up. If that's y, that's x. Sometimes you'll have a parabola open up downwards, but that's dependent on your sign. So if that was -x² minus 8x plus 8, then it would be going downwards. But I'm going to go over the shapes of graphs in a future video. But that's all you really need to know for leading coefficients of 1 and how to factor them. In the next video, I'm going to go over, if this was like a 2x² minus 8x plus 15, that's what we're going to learn to solve next. So if you like this video, please make sure to like. If you have any questions, comments, concerns, if I did something wrong in my math, please let me know and criticize me, because I should not be making mistakes in algebra as a college student. So please let me know. And again, thank you so much for watching.